Hello and welcome to Database Management Systems. I'm Javita Christie, and in this video I'm going to explain structured query language and some of the ways in which the select query can be modified to fetch the required data. We are going to see the where clause and how you can add a condition over there in order to limit the number of rows that are selected. So let's see this with an example. The query that we are going to answer is list project IDs of the projects with revenue greater than $40,000. And for this, I have attached here a screenshot of the query that I performed on my SQL Plus command line and the output that I got. So this is the screenshot. You can see the query that I wrote is select project ID because I've been only asked to do to select the project ID from projects, and in the second line I have written where revenue greater than 40,000. So this is the way you can specify a condition if you want certain rows to be selected. To select only certain columns, you can specify the names of those columns right here after the select keyword. But if you want to limit the number of rows based on a condition, then you need to specify that right here after the where keyword. So these are the IDs that I'm getting, and they are ADT4MFIA and RoboSPSC. Let's go ahead and check if these are correct or not. So this is the actual projects table, and it contains all these 6 columns, and you know that the IDs that got selected in the previous query were these 2 right here. So, and you can see that both of them have revenues which are greater than 40,000. And if you see the other two rows, which are the first and the fourth, you can see that their revenues are not greater than 40,000, and which is why they were not selected. Now we are going to see another interesting keyword in SQL, which is the between keyword, which also can be used along with the where clause. Let's see it with an example. If you are asked to list the department codes of the projects with a revenue between 100,000 and 150,000. So in this case, you could write it in this manner. Select dept code because you've been asked only to list out the department codes. And then you'll write down from projects where revenue between 100,000 and 150,000. So there's a between keyword here, and then you'll mention 2 values, the starting value and the ending value. And in between, you're going to write the and keyword. And you can see that this is the result. I'm getting only one dept code, and that is ACCNT. Let's go and check that. So this is my projects table. And if you can see, there's only one dept code that is ACCNT, which is right here. And if you check its revenue, yeah, it does lie between 100,000 and 150,000, and 100,000 is included in this. So that's why you got this as an answer. And you can see that others do not lie within this range, which is why you did not get that. Now we are going to see how you can specify a specific date in order to fetch the rows that you require. Let's list the project IDs for all the projects that started on or before July 1, 2004. So you can see here that there is the query select project ID from projects where start date is less than or equal to, and then you specify your date in this format 01-JUL-2004. And I'm getting these 3 projects, and those are MHappy, ADT4MFIA, and RoboSPSC. and we can verify that data within the table. So we were asked that we needed only those projects that started before July 1, 2004, and it says on or before, which is why we used less than or equal to, and this is July 1, 2004. So let's see. Before 2004, we have these three projects, and this is the one that's after, so this is not going to be included. And for the other three projects, we can see that these are the project IDs, and they are the same project IDs which we got when we implemented the query. Now we are going to see how to use the OR keyword within the WHERE clause. So this is the question. List the ID and descriptions of the projects under the departments with code ACCNT, CNSLT, or HDWRE. This can be written in this manner. First of all, you are asked only for the ID and the description. So we will say select project ID, comma, description from projects. And in the second part of the query, you will mention that you want only these three departments. And to do that, you're going to write down where dept code equal to ACCNT in single quotes, or dept code equal to CNSLT in single quotes, or dept code equal to HDWRE in single quotes. And the reason why we are using the OR keyword here is because if you use AND, you will end up getting nothing. And the reason behind that is because if you use AND, you're trying to say that there is some project that would belong to ACCNT as well as CNSLT as well as HDWRE, and that is not possible. You cannot have all three values at the same time in the same row and same column, which is why we need to specify OR in this case. So remember, we use OR whenever the name of the column is the same and we're trying to apply some condition. So most of the time in such cases, we use the OR keyword and not the AND keyword. And this is my output, and it's giving me three projects. The MOFIA audit project, robotic spouse project, and the download client. And let's check the results. So robotic spouse project belongs to the consulting department, CNSLT. Download client belongs to CNSLT. And MOFIA audit belongs to the accounting department. And the third one that we mentioned was the hardware department, but there is no project belonging to that department, so it did not come up in the results. So our result for this query is correct. Now let's see how we can specify two conditions using the AND keyword. We'll see this with an example. Suppose this is the question. List the ID and last name of all employees who work for department ACCNT and make less than $30,000. This is how you can do it. You can write down select employee ID, comma, last name from employees, where dept code equal to, and you can see here I've written ACCNT in single quotes. And then I have a second condition where I'm using and writing salary less than 30,000. In this case, you have been asked that both the conditions should be satisfied, which is why both the conditions have been mentioned. Instead of writing over here or, we have used and, because both are different columns and you can use and between two different columns, and it would, in this case, it's resulting in no rows selected, because in a minute we're going to check it. So this is the employees table, and you can see the condition was that the dept code should be ACCNT, and there's only one such person, which is pi r squared, and the salary should be less than 30,000 as mentioned here. It says less than 30,000. but you can see that pi r squared does not earn a salary less than 30,000, which is why he was not selected, and that's why we did not get any result in this query. Now let's see a very useful operator which is used in SQL, which is the like operator, which can be used to compare different strings with each other. So the like operator has the following functions. So suppose you are given a relation called instructor, it contains ID, name, and department name. And if you do select name from instructor with depth name like, and then you're writing in single quotes computer and then percentage. So what this means is you'll get the names of all instructors who belong to a department which whose name starts with computer. So you would get computer engineering, that would be eligible. Computer science and engineering would be eligible. Anything that starts with computer will match with this string. So percentage stands for 0 or more characters. Now, in the same way, the other things that you can add would be, for example, if you want engineering, so you want all the department names that end with ENGG, then you would do it in this manner. So the percentage in front means the last part should be ENGG, but in front anything can be there. And you can also use it with underscore. Underscore means one single character. So that means what you're trying to specify by writing this is department names with the second letter as S and then followed by 0 or more characters, because the first letter you have, for the first letter you've written underscore. If you specify 3 underscores, then that means you want department names that have exactly 3 characters. If you specify 3 underscores followed by percentage, then that means department names with at least 3 characters. So that is what all these expressions over here mean. And now let's see that see this particular query with an example. So this is my query. List all the information about employees with last names that have exactly 8 characters and end in WARE. So you can see how I have done this is select star from employees where last name like. Now we have to use the keyword like. You cannot use equal to here. You have to use keyword like. And then they have told that there should be 8 characters. And out of those 8 characters, the last 4 are WARE. So in front of that or before that, you're going to write 4 underscores. So what the line that you see here is actually 4 times underscore character. And after doing that, this is the result I'm getting. There are 2 people, Harry Hardware and Susie Software. So we can verify that. This is the actual employees table, and you can see that there are only 2 people whose names end with WARE and they have 8 letters in their names. So that is the correct result. Now we are going to see the distinct keyword, and what this keyword does is it allows you to select the names or items from a particular table without duplicating anything. So let's see this with an example. Suppose this is your query that says list all of the department codes assigned to a project and remove all duplicates. So this is the query, and you can write it in this manner. Select distinct and then in bracket depth code from projects. So depth code is the name of the column, and we are attaching a distinct keyword right before it. So what this does is tells you the names of the departments, I mean the codes of the departments it gives you, but without repeating anything. So if we look at the actual table, You can see that there are 4 depth codes. Admin, ACCNT, and CNSLT comes twice. But in the result of our query, you can see it shows only 3. And this is because we used the word distinct. If we were to remove this, then it would have shown you 4, which we already know when we use the select statement. So without distinct, it would have shown us 4 depth codes, but with distinct, it shows you 3 because CNSLT was coming twice and it removes duplicates. Now we will see how you can perform calculations within the column names that you supply while using the select query. So suppose this is your question. It says find the project ID and duration of each project. The duration means the difference between the stop date and the start date of a project. So it will tell you how many months are there between or how many days are there in between. That would be the duration. So for how long the project went on, that is the duration. And we can do that by writing this query. So we require the project ID. So we are going to write down select project ID, and then next we can mention the stop date and the start date, but we can use a minus sign. So we can write down stop date minus start date as duration. And you can see that here I'm using another keyword which is called as. So in the as keyword, when you specify a name, what happens is this column that you have calculated, which is stop date minus start date, comes here as duration. So you can see it got renamed, and this renaming is only for the time being, for as long as you're trying to specify this particular query. This rename is not permanent, so it's not going to change anything within the projects table. The select query never changes anything in the original table. It might change the data to display it. So it's only the display that's changing, but it's not the actual table that gets affected ever. So if I were to skip this part, that is as duration, then instead of duration over here, it would show me stop date minus start date as the name of the column, and that does not look very nice or presentable. So that's why sometimes we want to change it when we perform calculations between some columns or within the same column. So that's why it has been changed here. And you can see I'm getting the duration of only one project, and we can check why that is happening from the projects table. So you can see over here that all the stop dates are null except this second row, which is having a stop date, which means this is the only project that has finished. The others are going on, and that's why you cannot tell their duration as of now, but you can tell the duration of the project that is over. So 150 is what you're getting when you're subtracting this date, when you're subtracting this start date from the stop date 30th November. And that's why you're getting only one answer. The other things are null because you cannot subtract anything from null. So this is what you're getting. And now let's see a slightly more difficult example for calculations. So this is the question. If every employee is given a 5% raise, find the last name of that employee along with the new salary of the employees who will make more than $50,000. So this contains a lot of conditions, and you need to write down this query very carefully. Now, what does 5% raise mean? 5% means 0.05 multiplied by the current salary, because percentage means divide by 100. So you can directly write down 0.05 multiplied by the original salary, and whatever answer you get, you can add it into the actual salary. And if you do that, then you will be getting the new salary, which is here. But then from there, you need to display the last name and the new salaries of only those employees who will make more than $50,000 after being given the 5% raise. So now let's see how to do this query. So you can see here, this is the way I have written this query. You can write down select last name, comma, and then we are performing this calculation which I talked about. So you are first of all multiplying the salary by 0.05 and then adding this value into the original salary, which would give you the new salary. And then I don't want this to be the name of my column. It doesn't look good. So I want to change it and name it as new salary. So that's why I've written here as new salary. And of course, we are getting all this data from the employees table. So we are going to mention from employees. And then we are writing where salary. Now this is the tricky part. If you might be inclined to use the new salary column here, because you would feel that you have already renamed this column as new salary. But the thing is, this is only for the purpose of displaying the data. It has got nothing to do with the actual table. So within the actual employees table, there is no column called new salary. And that's why if you try to use over here new salary greater than 50,000, it would give you an error. You can go and try and check it out. And so that's why we need to use salary plus salary star 0.05, because if you don't, then you get an error. So that's why I've written the whole expression again and written greater than 50,000. And you can see I'm getting 4 people's names, and all these salaries are salaries after giving a 5% increase. And we can verify that from the original table. You can remember that here you are getting 73500, and if we check the original table from employees, you can see all the salaries are in multiples of 10. So except if, so yeah, all the salaries are in multiples of 10, and so you can see that over there are some changes, and you can verify it on your own whether this is exactly 5% raise or not. And you can see that everybody is not having a salary greater than 50,000. So for example, pi r squared, he has a salary of 40,000, and even if you give a 5% increase, it wouldn't be more than 50. You can see this Abe Advisor has 30,000. So obviously, even if you gave a 5% increase, it wouldn't be more than 50,000. So that's why this is not included. So the second and the fifth values are not included, but everything else is. Even Harry Hardware, because he has 50,000, and when you add 5% to it, it will definitely be greater than 50,000. So you can see that over here, he's having more salary than 50,000. Now we are going to see how you can sort the data which is present in your database, which is present in your table. So maybe sort it by a particular column and then display it in order to make it look better. And once again, we are only going to see how to sort the data for display. We are not discussing how to sort the data within your table permanently. That is not possible because we do not change the data in that way. We are only trying to sort it in order to be able to display it in a better manner. So let's go ahead and see this with an example. Suppose this is your query. Create a neatly formatted directory of all employees, including their department code and name. The list should be sorted first by department code, then by last name, then by first name. And let's see how you can do that. So you write down select, and then you mention all the columns that you require. So you need the first name, you need the last name, and you also need the department code because it has been asked over here. So you are mentioning all three from employees. And then there's this clause, and this clause is known as the order by clause. What it does is sorts everything in ascending order based on the column name that you provide after it. So by default, it sorts in ascending order, but if you would like to sort in descending order, you might have to write down the DESC keyword, which I'm going to show you in the next video. But for now, you can understand that this is a default sorting which is done in ascending order. And I need to sort everything by department code first, then by last name, and then by first name. So I'm mentioning order by first department code, then the last name, and then the first name. And then this is the table that I get. You can see over here that the depth code is sorted. So you have ACCNT first, then admin, then CNSLT, which is coming twice. Now, when it is twice, you know that it cannot be sorted because both are same. So then it is sorted according to the last name. So the last name is advice and software. So advice comes first in dictionary order and then software. And then finally, HDWRE is the next depth code which is used. So Harry Hardware comes here. And we also have a department code that is null. So null value always ends up in the end of ascending order. So that's why it is coming in the end over here. So this is how you can perform the order by clause, and you can obviously verify that using this table right here. There are 6 employees and these many depth codes, and you know how it got sorted. So you can verify it from this table if you would like to. You can go ahead and perform this query. And I'd also like to tell you to download or view the document that's linked in the description box. This is a document which contains all the queries and the syntax of all the queries that are performed in this video, and would be helpful if you were practicing along with the video. And please watch the next video for more on SQL. Thank you.